In this video, we are making this crumbling peeling off pieces simulation in Blender. Let's start. Here I have this statue model from Fab. It already has a decent mesh density for me to play with. If yours is low poly, feel free to add a subdivision surface modifier. First, we need to make a vertex group. So, in the Mesh Data tab, make a new vertex group and call it Mass. Go to Edit mode, select all the vertices and assign them to Mass. If you go to Weight Paint mode, you can see everything in red. Red represents a vertex weight of 1. Everything in red will not simulate. What I want to do is paint a weight of 0 to parts of the model, and every cracked piece in those areas will get simulated. But I'll do it dynamically in a non-destructive way. So let's undo this. Back in the object mode, add an empty sphere. I want everything inside this sphere to be simulated, to peel away. Right now you can see our empty is too big for the model, but rather than scaling down the empty, I scale up the model by 10 times. That way, distance between the vertices will increase by 10 times, which will help us to get better cloth simulation later. If you want to know more about that, check this video. Apply the scale. I want the peeling to slowly start from one place and then cover the entire mesh. So at the first frame, I place the empty around here and hit I key to make a keyframe. Then go to 1/60th frame, scale up the empty and place it like this to cover the entire mesh. Make a keyframe. When I play, you can see it has a Bezier interpolation. It eases in and out at the ends. So while cursor hovering over the timeline, I hit T and bring this interpolation menu and select linear. Now the animation will happen at a constant rate. For the masking, select the mesh and add vertex weight proximity modifier. Select the vertex group we made. The target object is this empty. Set the mode to geometry. In the weight paint mode, you can see something happening to the weight when the empty scales up. This modifier checks each vertice's distance from the empty, and the weight of every vertice inside this range gets subtracted. You can change the highest and lowest values to change that gradient. But it has no connection to the empty's actual radius. We need this gradient to dynamically update with the sphere. In this sphere, its scale is equivalent to its radius. So if I can link one of these scale values to the highest value, we can get the gradient we are looking for. So I right click on this X scale and select copy as new driver. Back in the modifier, right click on the highest and select paste driver. Go to weight paint mode and change this lowest value to be lower than the highest. You can see the highest value updating with the empty's scale, and we have the mass. To adjust the lowest value, right click and select paste driver again. Now we have a clear distinction between the vertices inside the empty and outside it. I want this gradient to be a bit more smooth. So I right click here and select edit driver. If you haven't used drivers before, you might get confused, so listen carefully and follow me here. To make the link, first we are telling Blender what type of property we are linking. Scale is an object property and the object we are looking for is called empty. Then we declare the exact path of that property. Here it is scale and this 0 is for X scale. Once we make that connection, Blender finds that value and outputs it as the driver value. To edit this, first I have to change the driver type to scripted expression. Here, when Blender found the connection, it assigned that value to a variable named scale, and that variable is what we are currently outputting. I can multiply this by something like 0.9 or 0.8, and you can see what that's doing. It grabs the scale, multiplies it by 0.8 and outputs that value. I think we need to adjust the scale of the empty a bit. Make sure once it's subtracted the weight, it should never gains it back like you see here. This could result in pieces that peels away and then come back to their original place, which I don't want. So I set the driver expression back to 0.9 and change the final scale of the empty. Key it again. Here in the fall off, you can pick one of those presets to adjust the gradient fall off. After that, we have this influence section where I can use any texture to distort or change this gradient. A while ago, I used this to make a logo reveal animation. You can check that video from here. Here, I will make tiny adjustment to the mask with a texture. Click New to make a new texture. I keep the coordinates as local and click this button to go to Properties. Here for the texture type, I select one of these procedural textures. I play with its size, intensity, brightness, and contrast to add a bit more variation to otherwise uniform masks. I'm going with this. We made the mask and now we need to break this mesh into pieces. Just like the previous tutorial, I start with a particle system. Set the start and end frame to 1. I reduce the particles amount to 500. Increase the lifetime to fit the animation length. Right now I set it to 250, but I might have to increase it later. Here in the source, I can change the distribution of the points. Make sure to check this box if you want the particles to use modifiers above it, such as subdivision surface modifier. Play with these distribution options to get something like this. Now if I hit play, I have this simulation which I don't need, so set the physics to none. Then to crack the surface using these particles as a guide, I add another modifier, this time explode modifier. Here for the particle UVs, we can select the current UV map of the mesh, but as I mentioned in the previous video, this could mess up our textures. So here in the mesh data, I duplicate the UV map and select that as our particle UVs. Check these cut edges to cut the pieces. If I enable the wireframe overlays, you can see that cuts happening. Or enable this size option and back in the particle system, set the particle size to something just below 1. Actually, I don't want to see the particles anymore, so in the viewport display, set it to none. These are our cracked pieces. I turn off the size. That was just to show you guys. Now for the cloth simulation. First, I add a plane and scale it up. This will be our floor and cloth pieces will fall onto this. So I enable collision for this. It looks like the plane needs to be a bit lower. I reposition it. Now select the statue mesh and add a cloth physics. Set the quality to 1. We don't need that many quality levels for this. I also reduce the vertex mask. Here in the shape, I select the vertex group as the bin group. When I play, only the vertices that have a weight of less than 1 get simulated. Parts of the vertex group that we distorted with a texture have resulted in these hanging pieces. Now, let's make the underlying layer. I duplicate our statue mesh. Since they are overlapping, I enable random color option in viewport shading. The duplicated mesh is now in green. I remove cloth physics, particles and every other modifier from this duplicated one. Then go to edit mode, hit Alt S to scale along the normals. Hold the shift key to slowly push the duplicated model inside the original one. If you see any pieces sticking out after that, you can go to sculpt mode and push them in. For example, in something like this, you can push in by holding Ctrl and painting over them. Like that. Since I want the cloth pieces to collide with this mesh, I enable collision for it. Now in the cloth physics of the original mesh, I reduce the collision quality to 1. Enable self collision and reduce these two distance value to almost 0. Since we scaled up the mesh, the cloth simulation will start to look very much like a slow motion effect. You can reduce that by increasing the simulation speed. I set this to 2. You can see pieces peeling off and sliding on top of the underlying mesh and falling to the ground. I increase the animation range to 400. Remember to increase the cloth simulation range and the particle's lifetime to 400 as well. To bake the simulation, here in the cache, I give it a name and enable this cache. This will store the cache file next to the blend file. If you see this grayed out, make sure to save your blend file first and hit bake. After the bake, I lost some footage of the recording, so here are a few changes I made. To see a real-time view of the animation, I set the output resolution to 50%. For output location, I made a new folder next to the blend file named test render, and I call the output anim_1. For the format, I choose FFmpeg4, encoding to MPEG-4 and quality to high. Then I pick a good view of the scene and hit viewport render animation. I got these results from that. After that, I changed the speed to 2.5, mask to 0.15 and baked again. Once that is done, I changed the output name to anim2 because I don't want to overwrite the previous one. Then do a viewport render animation. To view it, I go to render, view animation. And that's our simulation. If you like sticking around for more, let's see how I prepare this for the render. I renamed the duplicated mesh to underlayer and the original mesh to top layer. In the bottom layer mesh, I remove the material. Go to the shading workspace, make a new material. I give it this yellowish orange color. Set metallic to 1 and adjust the roughness. Add a noise texture. Increase the scale and plug a bump node to it. Plug its normal to normal. Reduce the distance and strength. Also the roughness. Adjust the color a bit. And make further changes to the texture to get a gold foil kind of effect. Since I'm rendering this on cycles, I change to cycles and pick a HDRI for the preview. I add an ambient occlusion node and use a color ramp to adjust the gradient. Then add a mix node, change to color type and copy this color to both inputs and plug this into here. For the color A, I made it a bit more red and darken it. Drag from the texture, add a multiply node, plug the color ramp into it. Duplicate the mix node and put it here. Change the type to float. Adjust the values like this and plug it to roughness. And for the top layer material, I add a clear coat. Adjust the roughness a bit as well. Another thing you can do is add input geometry node. You can use its back-facing mask to add different effects to front and back faces. Here I put a principal node and mix it with the original one. Use the back faces output for the factor. For the back faces, I make the color almost black. Then, to light the scene, I change the world color to black. Then add an area lamp and move it above the model. Increase the strength and place it like this. I increase the size for softer effect. Duplicate it one more time, place it to the side and change the color. Duplicate it again and place it behind and change the color to something like this. I increase the first light strength to 200. Increase the flow size. Add a material to it, make the color black and adjust its roughness. Let's add a camera. I keep it at 50mm and hit Ctrl-Alt-0 to align it to the view. Click this button to lock the camera to the view. Place it like this. Go to the first frame and make a keyframe. Go to the last frame, pull the camera back and add a keyframe again. I make a few more tweaks to the light's positions and strength. Then I add a cube. Scale it up to cover the entire scene. Go to Object Properties and set the display as to wire. Then in the shading workspace, I select the cube. Make a new material. Delete the principal BSDF and add a principal volume node. Plug it into volume. Reduce the density. Increase the anisotropy value. I do a few more tweaks to the lights. Then select the camera, enable depth of field and select the model as the focus object. I reduce the f-stop to 1.4 and the ratio to 2. Since we are using volumes, here in the render settings, light paths, I increase volume bounces to 4. For a bit of compositing, I make a new window to the side and change it to compositor. Enable the viewport compositing from here. Add a glare node and combine it with the render using a mix node. Set the glare type to bloom and mix to 1. Quality to high. Reduce the size and set the blending mode to add. Duplicate the setup and this time increase the threshold and size. Now adjust the mix amount of both effects to your liking. I duplicate the setup one more time and this time add streaks glare type. After that, I did a little bit of lens distortion. I did a bit more compositing and grading inside the DaVinci Resolve later, which I do not go into details in this video. Before my final render, I put a point lamp with high power behind the statue. Enable motion blur. Also, I changed the statue color to a grayish blue color. To render this out, I increase the sample count, set the output to EXR and pack it and upload it to Fox Renderfarm. Fox Renderfarm is a leading online render farm service that I myself have been using for over 2 years. Just upload the file, let Fox Renderfarm analyze your file for possible errors, and once that is done, you can do a test render to see whether everything is working fine. Once you confirm those frames, go ahead and submit the entire project for the render. and Fox Renderfarm will come back to you with the full render within minutes. No need to waste dozens of hours and days. Fox Renderfarm is fast, secure, and reliable. Don't just take my word for it. So many great projects you have seen over the years have been rendered using Fox Renderfarm. Sign up using the link in the description to get a $50 render coupon to start rendering. They have a big Christmas super sale going on, so don't forget to check that out to win even more rewards. You can combine this effect with my disintegration effects pack to make this type of disintegration effect. By the way, for a limited time, you can now grab my entire effects collection as a bundle for 50% off on Gumroad. Huge thanks to these amazing individuals for making these videos possible. Thanks for watching, and I'll see you in the next one.